Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. And tonight we're looking at the integral of cosecant cubed x. Recall this is the 11th video I think in the series where we're looking at each trig function and looking at the square, the integral of the square of that, the integral of the cube of that, and then looking at can we calculate the integral of that trig function raised to the nth power, and then the results we get in that video we compare it to what we came up with in the square and the cube video. So you'll know from our last video we said the integral of cosecant squared dx was minus cotangent. So now we're looking at the cube, and then I have something we're going to need off to the side. It was the integral of cosecant x. So instead of making the video so long, I went ahead and did that in advance. Okay, here we go. All right, the integral of cosecant cubed x. Now, how did we do this in the other ones? Yeah, we divided this guy up. If we look at this, the integral of cosecant squared x times cosecant x dx, there's some things we can do with this. We know we can integrate cosecant squared. We just did that in the last video, as a matter of fact. So let's use integration by parts. Let's look at DI method. So we have a plus. I probably need to scoop that over, don't I? See if I have. Alright, DI. Can you see that okay? Alright, so we have a plus minus. So let's integrate cosecant squared x, and let's differentiate cosecant x. Alright, if we differentiate this, it's minus cotangent x cosecant x. So that's the derivative of cosecant x. And then the integral of cosecant squared x is minus cotangent x. Alright, you know the method. So now this would equal, so we have the integral of cosecant cubed x dx equals minus cotangent x cosecant x. And then we have a negative times a negative is a positive. We're going to integrate this row, by the way. We'll integrate that row. Negative times negative is positive, times a negative is a negative. The integral of cotangent times cotangent, which is cotangent squared x cosecant x. Well, cotangent squared, I could change that to cotangent squared x equals cosecant squared x minus 1. Okay, let's see what we can do with that. As a matter of fact, let me just work down here and then we'll catch the rest of this up in a moment. So I'll substitute in cosecant squared x for cotangent squared x. Cosecant squared x minus 1 is this cotangent squared, and that times cosecant x dx. So now if I multiply cosecant x by everything in the parentheses, I end up with cosecant x times cosecant squared is cosecant cubed x. I'll separate this into two integrals. And then this negative cosecant x, don't want to lose that negative, because that negative times this negative gives me a positive, the integral of cosecant x dx. Alright, so let's catch everything up here. Minus cotangent x cosecant x, and all of that equals cosecant cubed x dx. Now you'll notice I have a cosecant cubed x dx and a cosecant cubed x dx. So and this one's negative, so I can add one here. But I add one to both sides. Okay, so that gives me obviously two of these. 2 times the integral of cosecant cubed x dx, and that equals minus cotangent x cosecant x, these cancel, plus the integral of cosecant x dx. Well, I don't want 2 of these, I only want one of them, so I'm going to multiply this by 1/2. Let's keep that negative. Alright, so these cancel. I end up with just the integral of cosecant cubed x equals minus 1/2 cotangent x cosecant x plus 1/2 the integral of cosecant x dx. Now I'm going to rotate the camera around here so you can see all of that. You'll notice this is very similar to the integral of secant x. Same concept. If I want to transpose this, get it into something I can work with, I'll multiply this cosecant x by cosecant x minus cotangent x. And the logic for that is, once you go through and distribute that to the inside, you end up with cosecant squared x minus cosecant x cotangent x over this. Well, if you let u be what's in the denominator, its derivative is what's in the numerator. So this minus cosecant x cotangent x plus cosecant x dx, all of that is du. So I end up with the integral of du over u. So if I integrate that, that's the natural log of u. So that becomes the natural log of cosecant x, the natural log of the absolute value of cosecant x minus cotangent x. Now in this case we have that, that's what's on the inside here. So it's 1/2 times that, times the natural log of cosecant x minus cotangent x plus c that I left off in my last video, minus 5 for me. Okay, so that's the integral of cosecant cubed x. That comes out to be this guy right here. Alright, that's the integral of cosecant cubed x. Why are we doing this? We're trying to grow our minds, but mainly together we want to build a better tomorrow and do that through math. Okay, that's all for now, guys. Study, 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 and we'll talk to you next time. Thanks.